Hey, I'm Amanda Olson, mathematics instructor here at Metropolitan Community College. We are looking at problem 12 from section 4.4 of our online calculus course. So this problem asks us to determine the area of a given region, and it's actually the region below the curve y equals x plus sine x. This graph provides us with a nice visual. This problem provides us with a nice visual of the function. And so it graphs for us the line or the curve really of y equals x plus sine x. And then it also has it from x equals pi to x equals 0. So that's the area we want to find the region of. So we can find the area of the region under this curve by evaluating the definite integral of the curve. So taking the definite integral of x plus sine x with respect to x, and we want to specifically look at it from x equaling 0, which is the lower bound of x, or the left bound, and then the upper bound of x, which is pi. So you want to evaluate this definite integral. Some other resources that you might want to have handy for some of these trig functions are the trig formula sheet, the formula card that you're allowed to use on the test, and then make sure that you're familiar with the trig antiderivatives. And you can either, have those memorized. You won't be provided with the antiderivative trig formulas on the exam. Okay, so let's go ahead and evaluate this definite integral. So the antiderivative of x with respect to x, we apply the antiderivative power rule. That's going to be x squared over 2. And then the antiderivative of sine is negative cosine of x, because the derivative of sine is cosine. The derivative of cosine is negative sine. So the antiderivative of sine is going to be a negative cosine. And that goes from x equals 0 to x equals pi. So then to evaluate this definite integral, we substitute in pi for x, and then subtract 0 substituted in for x. So we get pi squared over 2 minus cosine of pi minus 0 squared over 2 minus cosine of 0. This gives us pi squared over 2. Cosine of pi, if you think about on the pi circle, or on the unit circle, that's going to be a negative 1. And then if we distribute this negative here, we get a minus 0, which isn't, we don't really need that. But cosine of 0 is 1. And so then we'll have a plus 1 when we distribute that negative. Okay, so we end up with pi squared over 2 plus 2 for our final result. And then we can approximate that if we want to. I would leave it with pi because pi is exact, and anything that you convert it to in terms of like a decimal approximation, it's going to be an approximation. So I'm actually just going to leave this as it is, but you could approximate it if you want to see, like, does it have value or something, but it's definitely going to be positive. So 9 halves plus 2. So I'm confident in that answer. Thank you.